let's do another example of applications of trigonometric functions. So we've got the population of rabbits on Sarah's property, P of t. First probable issue of that, P of t, over time, t months over a calendar year can be modeled by the equation. All right, so sketch the graph for a 12-month period. Now, could use your calculator to sketch this graph, but I think it's going to be faster to do it by hand. So amp is 8, period is 2 pi on 3, which is 6. Scale is going to be 6 on 4, which is 1.5. All right, it is a negative cosine graph, so positive cosine graphs look like that, so it's going to invert that, so it's going to start low. All right, how low is it going to start? The mean line's at 20, it's going to start down at 12. All right, so it's going to go up to the mean line after 1.5, then it's going to max at 28. So 328, back down to the main line at 4.5 and min at 6. It's just going to do it again. Now it minned at 6, which matches the period, so that's always a good sign as well. Back up. So now I just go by symmetry, and this should leave me at 12. No, I've stuffed something up there. Yeah, there it is. All right, let's have a look. Oof. Try that bit again. That's all right, I'm happy enough with that. 0, 12, what's that, 3, 28, 6, 12, 9, 28, 12, 12. All right, let's get stuck into it. Find the populations of rabbits in April. So that would be P of 4. Now, bad question here, by the way. Find the population of rabbits in April. Right, when in April? Okay, middle of April, end of April, start of April. So let's edit this one here. Okay, so I'll just show you how the editing process does work in methods here. So if these are the questions here, I'd have a problem with this one. So find the population of rabbits at the start of April. Right, so that would indicate that we've got P of 4, which we can see is roughly 23 rabbits. So let's try it and see. Now this will be, yep, it's an exact value. So P of 4 equals, I'm just going to do it over here so I can see the function. So P of 4 equals 20, take away 8 times cosine 4 pi on 3. 4 pi on 3 is there. That's negative a half. So 20 take away 8 times negative a half is 20 plus 4, which is 24, which sounds entirely reasonable. So 24 rabbits at the start of April. Okay, now if that wasn't there, you could give anywhere between 24 and the end of the month. Okay, so it's just too open without that disclaimer there. Find when the population is the greatest and how many rabbits there are then. Okay, so when does that happen? So after 3 months, so at the start of the 3rd month, start of the 9th month. So at the start of the 3rd and the 9th month, there are 28 rabbits. All right, find how long is the population less than 15 rabbits in the first 12 months. All right, so I'm just going to give you a quick rundown of how to do this kind of a problem. So what we would be doing is saying, hey, function, when are you equal to 15? All right, so when we define this function, and let's just check that other one, f of 4. Yep, that was 24. All right, so yeah, we can do p of t, so f of x, let's do a solve. F of x equals 15 for x. And what it's going to do is this solve here will give us a general solution because f of x continues for negative infinity to positive infinity according to the calculator. It doesn't know that there's only 12 months in a year. Okay, so we can give it a domain 0 less than x less than 12. Then it narrows down the value. So we can see here 0.9 is one of them. Let's have a look at the graph. 0.9 would be there. There's, yeah, that looks around about right. All right, now here's how we do these problems though. All right, so I'm going to draw a line along here at 15. And what I hope you may notice is something really, really important. This bit here is exactly the same shape as this half of this bit here. And it's the same shape as this half of this bit here. And it's this part here as well. So I've basically got 1, 2, 3, 4 bits of the same thing. So the strategy with these ones will be, I want to find out how long it takes from there to there. Then I'm going to multiply that value by 4 because there's 4 bits of the same amount. That bit there is going to be the same as that bit. I'm going to have like that bit and then that bit. Okay, so 1, 2, 3, 4. So all I need to do is find 1 and then multiply that value by 4. All right, so P of t equals 15, where t is an element. So I'm only going to go hunting for the very first solution. So between 0 and 2. Okay, and it's going to give me that 0.91. Let's just double check. Yep, there it is there. All right, so t is equal to 0.85529 dot 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 dot. All right, so what that means is I've basically, my working out has said I want to solve the function for 15 somewhere between 0 and 2. Now you need to put that in. If you don't put that disclaimer in, then you've got to give a general solution. You can't just go t equals 0.855 blah blah blah. Okay, you've got to narrow down your search range. All right, so then with that t value, what I'm going to do is go 4 lots of 0.85529 dot 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 dot. So let's grab this value here. Equals 3.421187 dot 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 dot. Okay, so for how long is the population? Now, well, what's the exact answer here? Well, I mean, this is again a pretty poorly written question, and I'm okay with that because you can sort of see the discussion that we'd go through. So for how long? Well, what do we want to do to the nearest day? Exact value? The exact value doesn't work. I mean, if we look at this, if I try to drop this into standard, then yeah, you can see there that like that's still an approximation of the standard anyway. So we're not going to get the exact value here. So we do want the decimal approximation. And so let's just make a correction for how long correct to 1 decimal place is the population less than 15 rabbits in the first 12 months. So therefore 3.4 months it would be to 1 decimal place. All right, so what I'll do is give you or pass on that worksheet 1, which is the applications. I'll upload a copy of last year's applications problem as well on trig functions because the girls certainly struggled with that. And yeah, you can continue to test yourself out against those problems.